Hi all. So I said in the post there, we're moving on to the physics section, and we're going to start off with some measurement in units. So this is chapter 27 in your textbooks. Begins there on page 294. So you can go through the chapter and also look at all the key points. The main thing around this is just looking at the idea of standard international units, or SI units. SI units are the base unit in which we measure all the different things. So we work with the metric system. You may have also heard of the empirical system. So when we talk about length, we talk about the meter, mass is kilogram, time is second, temperature, now technically it's Kelvin, but we in everyday life actually use degrees Celsius, okay? So it's really important that we use the SI units when we're measuring things. So you may have heard of like feet and inches when you're measuring height, or pounds and stone when measuring weight or mass, and possibly miles when measuring distance. Those things are the empirical system, and while they are a valid unit of measurement, we don't use them as a unit of measurement in science. Okay, so it's really important that we sit with the metric system. You would have probably covered some of this stuff in maths already, but the idea, I suppose, that in length, you have obviously your meter. 1 meter is 100 centimeters, and 1 kilometer is 1,000 meters. The term kilo means 1,000, and the term centi means 100, or part thereof. So the chapter moves on then, looking at different ways of measuring length. Using there a meter stick, optiometer, trundle wheel, Vernier calipers. If you're unsure of how to use any of those or what they mean, just put them into Google and go on YouTube how to use them, and it'll show you little videos of how to use them. Then getting on to mass, the base unit there is the kilogram, and we measure that using a mass balance. Okay, again, you can have 1,000th of a gram, which is a milligram, and then you can have 1,000 kilograms, which we call a ton. Time, then the base unit is seconds. Obviously then you can have 60 seconds in a minute, 60 minutes in an hour, and obviously 24 hours in a day, and so on. And temperature, as we said, is the Kelvin scale, but generally what we use is the Celsius scale. Now the Americans use a thing called the Fahrenheit scale, so they're all kind of variants of each other, but the one we will focus on will be the Celsius scale. Okay, so what we say is that the boiling point of water is the 100 degrees Celsius mark, and the freezing point of water is the 0 degrees Celsius mark, and then that's split up from 0 to 100. You can have temperatures of less than 0 degrees Celsius, you can have temperatures of greater than 100 degrees Celsius, so make sure that's not just 0 to 100, you have like minus 20 or whatever else, you put a scene that would met air and so on. That goes on then, and looking at area, which we talked about probably in maths. So you've known area is the length multiplied by the width. So for regular shaped objects like squares and rectangles and so on, it's pretty straightforward. I think to remember the unit then for that would be centimeters squared or meters squared, depending on what units they're in. And you can also get the area of an irregular shaped object. So if you look at the squares on your science laboratory copy, if you kind of get your hand and look at all the full squares, and they count as 1. So every full square is 1 centimeter squared, because that's what those little squares are inside in the laboratory copy. And then if you look at the ones that are, say, partly filled, they also count as 1. And any square that is half or greater, you count as 1. But any square that is less than a half, you don't count at all. So you can get kind of a variation. And again, there's a YouTube video on that. Volume then is just how much space is in something. So like a milk carton, you can buy 1 litre milk cartons, or 2 litre milk cartons, or 3 litre milk cartons. So that's the amount of liquid that will fit in those particular cartons. Regular shaped objects, you can get the length by width by height. So for a cube, rectangular prism. In maths, I don't know if you've done it yet, but cylinders, like it's pi r squared h, cone is 3rd pi r squared h, and a sphere is 4/3 pi r cubed. They're all forms for calculating it. Generally though, we look at the regular shaped objects, like a rectangle and cubes, so length multiplied by width multiplied by height. Because we multiply centimeters by centimeters by centimeters, the volume will be measured in a thing called centimeters cubed or meters cubed. Okay. Lastly then, you're looking at the idea of measuring the volumes of liquids. So what we do is we use a thing called a graduated cylinder, or a measuring cylinder. So you can see it there, you have little marks in, you pour some water in, it'll come to a mark. Now, one thing about water is water has a thing called a meniscus. So basically water will cling to the edges of the glass and actually forms a little bit of a curve. So when you measure the volume of a liquid, you should always read it from eye level. So get down your hunkers, whatever you have to do, and read straight across and look at the bottom of the curve, not the top of the curve. Okay? So some people read it from the, from here, right? It's a great color, but you need to read it from the bottom of the curve. Okay, can close that off there. Okay, and then if you want to get the volume, so regular shaped objects are fine. So squares, rectangles, cubes, cuboids, that kind of stuff. Water, you can pour into a graduate cylinder or something big that it can be poured into, that you can measure little gradients on it and measure from the bottom of the meniscus. That's all fine. Problem is if you have to measure the volume of a stone, say, or a golf ball or one of those things where it's not regularly shaped. In other words, there isn't straight edges, or there isn't a perfect sphere, or whatever else it may be. In that instance, what you do is you can take a graduate cylinder and fill it, say in this case here, they fill it to the 50 centimeters cube mark. They drop the stone in gently, obviously not to break the glass, and the volume rises to 70. So that means the reason the volume rises is because of a thing called Archimedes' principle. So when the stone falls in, the volume of the stone displaces water and pushes the water up. So the increase in the volume of the water is the same as the size of the stone. So in this case, we can deduce that the volume of this stone is 70 centimeters cubed. Okay, now that will become very important when we get on to our next chapter, looking at density and how to use the overflow can. This guy here is just using the same thing. The overflow can, you fill it to the very, very brim. You put the spout just over the graduate cylinder. No, it'll be empty beforehand. Gently lower your stone in. What happens is the stone goes in, water rises, and the water comes out. And then you can measure the amount of water that comes out. And the amount of water that comes out here is equal to the volume of the stone there. Okay, and then you can read in through there about accuracy and precision. Okay, so guys, what you have to do then for homework is, I have in your assignment, I have questions 1 to 9 here, where I want you just to do the answers to those questions, and then here questions 1 to 4 on the knowledge and understanding bit. Okay, also what I've done is I have linked you to a SkullNet website, which is basically this website here, and there are a load of different activities that you could actually carry out at home if you have a weighing scales and a ruler. So a lot of those things are actually quite interesting. Some of them are videos and so on. There's 2 pages, so you have, that's the first page, and if you click in here, then you have the second page. But now the ones on electricity you can leave out, okay, because you haven't done electricity yet. But everything else is fine. So finding length, making accurate measurements, and some very good activities there that you could be doing at home that will help you maybe deepen your understanding and knowledge of this particular chapter. Also as well, just attached to your work, I have put in the, where is it now? This. So in your assignment, as I said, you have the questions at the end of the chapter, but you also have this little worksheet as well. So there's like 2 pages or 3 pages, that worksheet. Just again, give the answers to that and submit that along with your assignment as well. Okay guys, take care. Bye bye.